Show that the total number of line. Show that the total number of line of force is dependent on the charge. Is dependent on the what? On the charge and not on the what? Radius of the sphere. As state theory or conclusion, you can draw. Okay? You can draw from this what? Expression. Three conclusion you can what? Attention. Whenever you are drawing your line of force, okay, sorry, whenever you want to do the proving, a number of line n is equals to EA. Your n they represent a number of what? Line of force. Okay, your E they represent what? Electric field intensity, and A represent what? Cross sectional what? Area. Now the way it is like this, our number of line like this is depending on the radius, because inside the electric field, okay, there is what? A radius. Inside our cross sectional area there is also what? A radius. Are you following? Now what they're asking you to prove now, they want you to prove that in such a way that your number of line will not depend on what? On the radius, but instead on the what? On the charge. Now how do you go about that? And from here you can simply call this place equation what? Equation 1. For our electric field, our E is equals to Q F over what? Q. And please pay attention. According to this, we also have E equals to the K Q then over what? R square. Please pay attention. Now from this place, we already know what's Q. Okay, how did they got this? They got this expression from your force. Force is equals to the K Q1 Q2 over R square. Is it not? Now, if you make F the solid of the formula here, we have F equals to what? EQ, isn't it? If this one is F1 and F2, F1 is equals to what? F2. What's our F1 here? Is KQ1 Q2 over R square equals to what? EQ, right? This can cancel out one of this, is it not? And then you have it as E equals to KQ over R square, isn't it? So this is the expression we are making use of. Okay, so from this place, you can simply say, recall that our E is equals to KQ over what? R square. Are you following? And don't forget, where K is equals to 1 over 4 pi epsilon naught, is it not? We can substitute this into this place. True of us. Please pay attention. And then we have it as E equals to what's K? 1 over 4 pi epsilon naught. Then times what? Q over R square. And if you multiply this, we have it as E equals to Q over 4 pi epsilon naught R square. So you can call this equation what? 2. Then y for surface area of a sphere, our A is equals to 4 pi R square. Okay, what you do, you can call this equation what? 3. So you substitute equation 2 and 3 into equation what? 1. So you put equation 2 and 3 into what? Into 1. And our equation 1 is what? N equals to EA. So from there we have it as N equals to what's E? Is Q over 4 pi epsilon naught R square times what's area? 4 pi R square. We have 4 pi R square. So from there, we have it as N equals to, this time we have 4 pi R square Q all over what? 4 pi epsilon naught R square. What happened? 4 can cancel out 4, right? Pi can cancel out pi. Then rate R square cancel out R square, is it not? So what's left there? N equals to Q over epsilon naught. Now don't forget, normally if you want to get the value for n here, you can get it because your Q, which is charge, has a constant value. That 1.602 times 10 power minus 90 colon, right? Even permittivity of free space also has its own work value, which is 8.854 times 10. So if you divide the two, you can easily get the value for what? For n. That means with this like this, your n is not depending on the radius anymore. True or false? Is n depending on radius? No. It's only depending on the what? On the charge and your permittivity of free space, isn't it? All right. So this is the expression you were asked to prove. So you can call it question 4. Now this time around, you were asked to what? To state three what? Conclusion. Okay, you can draw from the expression. Now number one, conclusion. Conclusion. Number one, line of force originates or terminates in space surrounding the sphere. That's number one. Number two, every line of force is a continuous is a continuous line that terminates by the positive charge at one end. Terminates at positive charge at one end and negative charge at the other what? End. Then number three, line of force never intersects. Line of force never what? Intersects. Like they never meet each other. Okay, so these are the conclusion you were asked to draw at. Number one is what? Line of force originate or what? Terminate in space surrounding what? The sphere. Because that when you are drawing your line of force, okay, you start from positive to negative or negative to what? To positive. And if you observe, you always have your negative charge at one end, right? And the positive charge at the what? Other end when you have unlike what? Charges, isn't it? And another thing again is that in terms of line of force, do they meet each other? They can never walk cross what? Each other. Are you following? Neither can they meet each other. That's why they say line of force never what? Intersects. Are you following? All right. So this is what you are asked to prove, and this is the conclusion draw out from your what? Expressions. So you can copy that.